Yes, yes, sir. You are
Good
audible.
afternoon, Harsh.
Uh, so, sir, can we wait for 2 to 3 minutes and let other will join?
Sure, sure.
So, welcome and good afternoon to all of you. Now we are going to start this third session of today's FDP. Today we have Professor Rahul Johari for expert in this session. Uh, Professor Rahul Johari is a teaching at University School of Information and Communication Technology, Guru Gobind Singh Indraprastha University, New Delhi. Presently, he is the head of the software development cell and head and founder of Singer Security Wireless IoT Network Group of Engineering and Research Lab and ACM at the US ICT chapter. He is PhD from Department of Computer Science, University of Delhi. He is Microsoft certified professional and ODEM certified blockchain faculty. He has awarded with the Best Teacher Researcher Award at GGSIP University for the academic year 2013-14 and 2014-15. Professor Johari is a recipient of the FRGS Faculty Research Grant Scheme of GGSIP University for the academic year 2016, 18, 19 and 20. He was chosen for Albert National Mauritius Achievement Award for the 2018-19 for professional excellence in field of computer science. He has 4 international patents and his 5 research papers have been awarded as best research paper in international conferences. He has delivered 60 keynote invited talks in reputed foreign with 75 Scopus Index publication, 20 book chapters, and over 100 publication in leading IEEE, Springer, Elsevier, and ACM Index General. His current H index is 12. So we are happy to have such a speaker for our this session. So I would like to invite Professor Johari to start his presentation and enlighten us. Professor Johari. I think some network issue. So, am I audible to participants?
Yeah.
Okay. Wait. Okay, sir, joined us. Okay, please, sir.
Yeah. Good afternoon, Hershey. Is it audible?
Yes, sir. Yes, sir.
Okay, fine. So at the outset, I would like to thank Professor Vikram Singh ji for inviting me to deliver a talk on blockchain technology. So it's afternoon talk after the lunch, so it's going to be a bit sleepy for every one of you also. But I will try to make the lecture as interactive as possible. I will try to keep it light so that it will become understandable also, and you can also enjoy the session in the post-lunch time as such. Now, I will start with the basics of the blockchain technology, rather starting with the basics of the information security first, then we'll come to the blockchain technology. And then there's a very good initiative by the government of India. They have set up a MHRD virtual lab. So if time permits, I'll try my best to give a demo on that virtual lab also, so that you can share that virtual lab with your students also in your colleges, so that they can also get a good exposure of working on the blockchain technology. So I'll share my presentation and then we can start. Is a voice audible and slides visible? Anyone can say quick yes or no?
Yes, sir. Yes, sir.
Okay, great. Thank you. So we'll discuss about security using the blockchain technology and how the emergence of the blockchain technology has helped the information security world in improving the quality of the level which are already there in the area of security, and how blockchain has added to more value to it. So this is a brief profile about me, which Professor Harsh has already introduced. I'm working with Gobind Singh University, Dwarka. We have a beautiful campus there. So if you plan to come to Delhi, you can always plan to visit our campus. And we're also coming a campus in East Delhi. So this is my number and mail ID. So if you've got any doubt regarding my session on blockchain technology, you can always drop me a mail at my mail ID, or you can WhatsApp me the message or the question on my phone number. So I'm heading there, the software development cell. We got to set up a lab there called Senior Security Wireless IoT Network Group of Engineering and Research, and the ACM at the USICT chapter. So this is a lab wherein I've been lucky enough to get very good students from the BTech and the MTech, and who have working along with me, and we have been able to carry out good sizable publications in our lab at the IP University. So this is going to be brief organization of the presentation. Need for security, few definitions, some wizards, heroes and villains. Now, Government of India's take on security, the contributors and researchers who have done a lot in the area, blockchain technology, the role of Satoshi Nakamoto, how blockchain works. We'll take some example from the Java programming language also. Then virtual lab scenario. So first thing first, the data security. Data security is a big buzzword in 2020 and in the years to come. So along with the IoT, the cloud computing and the big data, security is a new technology, rather not say new technology, but a technology with a very bright future in at least 5 years, in the next 5 years. What will happen after that, we can't say, because the shelf life of any technology in our industry is not beyond 5 to 7 years. So things changes very fast, very dynamic. So what will happen after the next 5 to 7 years, we just can't predict. But security is something which is evergreen. Whenever data is there, we always require technologies to secure and strengthen the data. So security will always remain there. There's a very beautiful proverb which I found on the web, which I want every one of you to silently read. Now this proverb is by the Sun Tzu. He's a Chinese author, Art of War. Now what he suggests that we should not take the things lightly. In simple work, if I try to summarize it, because we really do not know when our data might get attacked by the enemies. So we cannot be complacent in our position. We always have to be in the ready mode. But irony of situation is that we realize the value of security only when the data has been stolen, not before that. So that's the essence of human being. That's how we work also. We only realize, because if you look any organization, you keep on telling them that you try to develop the strategies or try to have the technology which can secure the data. They won't listen. They won't spend the money on that. But moment the theft take place, then they realize the value and the essence of the security of the data. So that is what the proverb also says, that we have to always be in the ready state, 24/7 by 365, something like that. Now, some few facts about data. We say data is a new oil, and that's very true, because if you look now, almost all the top-notch companies, be it Microsoft, Adobe, Amazon, Google, IBM, they want our data, our personal data, our professional data, because they have got huge crunch of the algorithms, which they want to test, and they want to test we are the case studies for them. So they would like to test their algorithms on our data. We also say data never sleeps, because somewhere some of the companies keeps on continuously processing our data. Maybe it's my bank, maybe it's my insurance companies, maybe it's if I booked a ticket on the aviation or the railway sector, those companies. So somewhere somebody will be fiddling with my data, though I may or may not be aware about. If I invested in the stock market, they will also fiddling with my data. So data never sleeps, continuously 24/7. Some of the companies are continuously processing your data. So we say data can either be freely accessible data, or it could be protected data. So freely accessible, like me, all my personal details, my name, my date of birth, my educational qualifications, my employer name, my spouse name, the place of my residence, it's all freely accessible data, or everyone in my social circle knows about this data as such. But yes, what about my financial data? My credit card numbers, my debit card numbers, my bank account numbers, my locker number, my biometric details. Now they are the data which is close to me, and they need to be protected. I can't risk that data of getting stolen in the market. Now the big question that comes to the people like us who are working in the area of security is, can the data be secured, or can the data be protected from the theft? That's one of the biggest challenge in the information security, which has been there in the last 20 years and will continue to remain there in the next 20 years also, because protecting our data is very, very critical. So data privacy and information privacy and security are big issues, and the challenges are a lot how to safeguard the customer's data so that it doesn't get theft and it doesn't get into hands of the cyber criminals. So if one cannot prevent the breach of the data, because we cannot prevent it, it's as simple as that, accept the facts. We cannot prevent the breach of the data. It's better to secure the data in order to prevent its misuse. So that is something what we can do efficiently and amicably. So information security is what the field is and what we look forward to, that will help, that will have a bright future, because a lot many things are going to happen in this particular domain. So in general, information security, we can say it's a practice of defending the information from unauthorized access, disclosure, disruption, destruction, a modification, and recording by unlawful means. So information security is an art, that how you protect your data from all these events which are going to happen moment you're online, moment your data is on the web, how you prevent the unauthorized access of your own information. So these are the challenges which every information security expert always face whenever he works in the area of the security. Now, who we are actually afraid of, who are real culprits in our information security? We are afraid of hackers. Now, these are the person who seeks and exploit weakness in a computer system or a computer network. And these may be motivated by many reasons, which could be sheer money. They want to earn quick money, so they are working for profit. Or they would launch a protest against the government policies or your organization policies. Or just for the sake of fun, they are doing for enjoyment, or somebody is posing a challenge to them, that can you do it? So they take it as a challenge and try to show that yes, they can breach into the system, they can breach into the network. So they are the real threat to our systems, both system software, application software, as well as the computer networks. And since this course is already built around that fact, so many speakers would also be discussing about the same things. Then other is what we say a cracker. Now he is a guy who breaks into the computer system either as a computer criminal or a cyber criminal, what we call black hat, or as a security expert, and that is popularly called as a white hat hacker. So a person has to decide a role, whether he is a information security expert, so he is donning a white hat, or he is acting like a cyber criminal, donning a black hat. And at times it may happen the same person can perform the twin task. So there are many speakers in the FDP who might have talked of ethical hacking also, wherein it all boils down to a single individual, that whether he is doing a hacking for a purpose or he is doing a hacking for posing as a threat to an individual or to the organization. I heard the name of Ankit Fadia, India's best known ethical hacker. He has done a lot in this area. He has published the research papers, the white papers, and even the books based on the ethical hacking, and even conduct the course on the ethical hacking. So it is the white hat hackers. They are often called as crackers. So person has to take the decision that what role he would like to. If he is working in security, whether he will work as a security expert and helping the law enforcement agencies or the governments in protecting the data, or he might just act as a threat to the entire cyber ecosystem and pose as a bigger threat and acting as a black hat hacker. Then we also call it script kiddies. So these are the non-expert who breaks into computer system by using a pre-packaged automated tools, usually written by the others, with almost little or no understanding. Now, the people who actually, the students who actually become script kiddie are the students who in the age group of, let's say, 14 to 18, because when they're in the 9th to 12th classes, because at that age they're learning the technology, and some of them are very, very fast, got a brilliant IQ, a very good logic, and if the technology really excites them, they become passionate about it. So they can spend hours and hours on the network, on the web, exploring the world, learning many new things, which can be good also, which can be bad also. So it's a very, teachers and student parents have a very important role to play nowadays, especially in the global pandemic world, where almost every student is hooked to the web, that what all they are exploring on the web, what all they are doing. So they need to monitor it, and if the parents are engineers or they are in touch with the technology, they will be able to understand the thing. But if the parents are simple, let's say arts graduate, and they do not know much about technology, so it's a really problem for those parents how to guide the students about all the how to keep an eye on the students what all they are doing it. Now during this age, they have got a lot of energy, a lot of potential, good IQ, and they can get distracted. So they might use certain pre-packaged automated tools. There are many of the free and open source softwares, which I think some of the speakers would have shared in the part of this workshop also in the FDP. Many number of the free softwares are available, which help us to penetrate into the system. Some of them are proprietary tools. Proprietary tools they won't be able to access. That's very clear. But regarding the free open source software tools, they get their hand, they lay on, and they try to breach into the system, and they might do something which is not expected of them. So unknowingly and unintentionally, they might commit a theft, and which can be threat to them, to their parents as well as to the society. And usually we say they are the outcasts of the hacker community, because some of them end up joining the anonymous hackers community on the web. There are so many number of professional hackers on the web, and it's a big challenge and to protect our data from all these people. And they are really intelligent, smart, good programmers, very good IQs, they are good logics. So they are just not everyone can become a hacker. We always say on a scale of 1 to 10, if the level of programmer is around 7 to 8, then the level of hacker is around 9 plus, because he's exceptionally good to become that kind of person. He's very good in mathematics, he's an excellent algorithm writing skills, and then a good knack of breaching into the systems to show, yes, that I have the capability. And then they earn a lot of millions of dollars just by breaching into the systems and network and stealing the data. Then we got about hacktivists also. They are also smart engineers, and these are the people who utilize the technology. They know how to use the technology to announce a social, ideological, religious, or political message. So there are many terrorist organizations, and they recruit the engineers based on the religion. And these engineers are they're well aware of the technologies, and then they help these terrorist groups to do to fight against the governments of that particular countries, and by just like defacement of the website, even on the common example of what these people normally do, or they launch the denial or the distributed denial of service attack with a bogus number of requests blocking the servers altogether. So they are primarily aimed for disruption in the society. That is what, because they want to make their presence felt for the government, that yes, consider our demands, consider our what we want from the government. So it's become easiest way for them to get the things done from the government. So activists is another professional hacker group which specializes for a particular domain, for a particular religious or the terrorist organization. Now let's talk of the information security in Indian context. So we have got something called CERT, or the Computer Emergency Response Team, which handles the computer security incidents. So CERT is there almost in every country. Every government has set up a CERT in their own nations. And the name was first coined by the CMU, what we call Carnegie Mellon University. So in India also we have got a CERT in New Delhi, the Lodi Road at CGO complex, their office is there. And some of the other very good initiative by the government of India towards information security are like establishment of CERT, establishment of DSCI, what we call Data Security Council of India. It's a private organization that works along with the NASSCOM, or rather under the NASSCOM, and they release various white papers. They come with a good knowledge of ransomware attacks, the various kind of the strategies which the government keeps on designing and developing for information security. So they work a lot in the area of the information security. Then we got Information Security Education Awareness, ISEA. And then around last 2 years or so, government has now made it mandatory for the appointment of CISOs, what we call Chief Information Security Officer, in almost all the organizations. Because earlier this thing was just like taken care of by the IT head of the company. But now government says we don't want to be just like an additional charge. We want a special dedicated nodal officer who can take the handle the security of the data belonging to that organization. So he is the person accountable for it. So nowadays almost every organization have started appointment of the CISOs, Chief Information Security Officer. So this is a site for the.
I'm sorry to interrupt. I think you're Just showing the first slide. It's still on the top on security using blockchain technology.
Are the slides moving or they're still?
No, they're still on the first one.
They're still on the first one.
Yeah.
Let me then stop and then restart again.
Okay, thanks. Yeah, now we see information security, education, and awareness.
Now is it visible?
Yeah.
Information is this visible now? It is moving. CERT.
No, sir, I still see information security, education, and awareness slide. I think it's number 15 or
okay.
And now it has moved to CERT.
So when I go for the PowerPoint presentation, I think there is a problem with it.
Yeah, now we can see a person moving as well. Speakers keep switching up.
Is it moving now? Is it moving? The slides navigating?
No, sir.
Oh, that sounds strange.
Okay, now it changed. I think there is some network lag. Now it's moving again. I think
is
there
it
is some
moving
network
now?
lag. Yeah, I see the cracker. Who are we afraid of? Computer security.
Okay, fine. Then I will not go into the presentation mode. I will just keep it like that.
Okay.
So we had discussed about the, is voice audible? Okay, fine.
Yes, sir. Voice is
okay, fine. So thank you for pointing it out and making it much more now visible. I was never sure that the slides are not moving. So we have discussed about the crackers. We discussed about the script kidding. We discussed about the hacktivist. And we were discussing about the information security in the Indian context. How the good initiative taken by the government of India and what our government of India is doing for the assistance of the information security, first identification of information security as a prominent domain in every organization, so that it should not be taken for granted and it should be given due importance, and the worth and the value of the data should be realized by the companies concerned. So this is how the CERT site looks like, Computer Emergency Response Team, since all of us are faculty members. So, and those of you who are very active in your colleges, you can set up an industry webinar or industry tour when the things normalizes after pandemic. And even you can take your good students who would like to work in the area of information security to the CERT headquarters in CGO Complex, Lodi Road. If you got any doubt, you can always contact me. I can help you. I will share the information with Professor, and he will get in touch with you and then also help you to check to that particular place so they don't have any problem. Now this is how the information security education and awareness looks like. This is also a very good site by the government of India. Now they are doing a lot in this area because they are helping the students as well as teacher to realize the worth of the security by attending many number of the workshops which they continuously organize. So if you are again active in your college and would like to do something in this area, so you can approach the ISEA, Information Security Education and Awareness Portal, and you can drop a request. They will give you the initial funding, and this funding will help you to organize a talk or a lecture or maybe conduct a workshop in your college by the ISEA experts. So they do a lot in the area of information security, especially in the Indian context. Then this is how the Data Security Council of India portal looks like. They're also doing a lot in the area of the information security. Now let's come to the blockchain technology. That's our prerequisite. Now what all we can do about the blockchain technology. So some of the prerequisites we always say a person should have when he's working in the area. He should have a good knowledge of cryptographic techniques and cryptographic algorithms. Now, since many speakers are already coming to this workshop and will be delivering a talk on the cryptography also, we say that we have got two branches of cryptography, symmetric and the asymmetric. Now, in general, how do we define a cryptography? Simple art which gives you the ability to protect your data in the presence of adversaries. So I should have the ability to protect my data even when the enemies are there. I should be able to transmit my data in a safe and secure manner so that they do not come to know about that yes, secure data is being getting transmitted on the web. So initially we got a plain text, Then we apply any cryptographic techniques and algorithms. We get a ciphertext, and that ciphertext is transmitted to the destination. And in the destination, the ciphertext is decrypted back, and then we get the original plain text. So when we carry out the encryption and decryption, we normally use a key. Now that key plays a very important role here. So either what we can have is a single key, or I can have a pair of keys. So that gives me the idea of two kinds of cryptography, symmetric as well as asymmetric cryptography. So either I can use a single key for carrying out encryption and decryption, or I can use a pair of keys for carrying out encryption and the decryption. So we accordingly have symmetric cryptography and asymmetric cryptography. And both of them have their own importance. Just like technique is important, so is the key. हम इसे इस तरह से भी समझ सकते हैं कि जैसे एक ताला है और एक चाबी है. अगर चाबी खो जाए, then we can approach a locksmith and we can show him a lock and we can say, kindly prepare a duplicate key for us, and he will do a favor. He will charge a good amount of money, 100 to 200 rupees, and then he will prepare it. So algorithm के साथ we have got a चाबी, but we cannot do the other way around. अगर ताला खो जाए और हम चाबी लेके जाएं उसके पास और हम कहें कि आप डुप्लीकेट ताला बना के दे दीजिए हमें से, so he can't do that. So point I'm trying to say is just like the tala and chabi are highly dependent upon each other for the efficiency of this, for the security of the house or the security of the room from where they have been applied. Same way for the algorithm and a key. The key will drive the algorithm. Same way, if you take the same example to the lock and key, we have got various levers of lock. We have got a 5-lever lock, 7-lever lock, 9-lever lock. That means we are increasing the level of complexity within the algorithm. We are increasing the level of complexity within the lock, so that when the burglar comes in or maybe criminal comes in, he will have a tough time breaking a lock. So same way, it depends upon us people working in the area of information security, that we try to develop algorithms which are complex, which are difficult to crack and difficult to decrypt as such. But then it also imposes the challenge, because I work in the area of wireless network also. We cannot devise too complex algorithms also, because these algorithms, when we're deployed on the handheld wireless devices, they are going to drain off the energy of the device. So, and we all know in the handheld devices, one of the biggest challenge is the node's battery life. Almost every day we keep on charging our smartphones. We also carry the charger also. We carry the other devices with the wherever we find a port, we try to plug in, because that's one of the critical areas of the handheld devices that they require continuous charging. So I cannot devise algorithms in terms of security which drain a lot of bandwidth or a lot of energy of my smartphone. So that introduces something called the lightweight cryptography, or the LWC, which is a cryptography where you do not compromise on the level of security, but you try to design and develop algorithm which work efficiently on the smartphones, and they do not drain much of the energy of the battery of the smartphone also. So yeah, very challenging area. You just can't come up with the algorithm just like that. We are along in a lab also, we have got other student like Harshit is one of them, and the other students are also working. We are continuously trying to develop the algorithm which can help us to achieve that level of the security we achieve the level of efficiency in the smartphone without compromising the level of security. That's the first two things which you must have a knowledge of, a blockchain expert. Third is a good knowledge of hashing. Now hashing hashing again, if you go for a technical definition, it's there on the web, which I think all of us are teachers, they can always go through it. But a simple art of again developing a technique using any of the cryptographic techniques and algorithm with the primary objective to protect the data. Now the input can be my alphabets, my numbers, my special characters. The hashing technique can take any kind of the input as such, but it should be able to develop a proper ciphertext, and which is not easy to crack with. Now first thing, I can design my own hashing technique, or I can use a predefined hashing algorithms. Just like we've got the MD5, the message digest 5 algorithm, or we've got a SHA secure hash algorithm, because these are the algorithms which are predefined, and they have also taken own time, many years to reach to a stage of stability and maturity. So either we can use the predefined algorithms, or we can devise our own hashing technique, to hash the data, because hashing is a backbone of the blockchain technology. Without hashing, we cannot carry out the design and the development of the blockchain. And the last, which is just like simple, but it's very important skills in a programmer, what we are looking for: map skills, mathematics, algorithm, and programming. So these are very important skills for a person who was working in the area of the information security and the blockchain technology in a particular. And when you are also teaching in your own class, if you find students who are very good in these skills, they are the person to whom you can nurture them and bring them in the area of security, so that you also are able to guide their careers and they will also blossom like anything. So, and it's a very deadly combination. The person who is good in mathematics, algorithm, and programming, his career will skyrocket like anything, because these are the typical traits which are very difficult to find all the three in a single individual. So these are some of the security stalwarts which we always appreciate in our information security. We've got the Rivest, Shamir, and the Edelman. So they have done a lot in the area of information security, and rather we say entire branch of the computer science standing on the shoulders of these three persons. And for the effort, they were also given the ACM Turing Award way back in the year 2002. Now, if you look at this award, they started somewhere in 1965, and it's 2020. So almost 35 plus 20, 55 years have gone by. This award is given every year to a person or a group of persons for outstanding research in the area of the computer science. So considering the number of engineers we produce every year, so many engineering colleges, so many universities in India we should have been able to get at least 20 or 30 awards in the last 55 years. But unfortunately, we have got only one award way back in the 1994, and it was awarded to Professor Raj Reddy for doing some good work in the area of artificial intelligence when he was based in US. So that also speaks the irony of our education system somewhere, that we are not able to produce the engineers par excellence who are able to do outstanding research, breakthrough research in the area of the computer science and information technology. And ACM Turing Award is dedicated to that only, because we do not have a Nobel Prize in computer science. Nobel Prize is awarded in the pure sciences like physics, chemistry, biology, but not in the computer science. So we do not have that, but the prize money is almost of ACM Turing Award and the Nobel Prize is almost same. I don't say exactly same. It can go every up and down every year. It depends upon how much amount of money they have got in funding these awards, but it's a huge amount of prize money, running into millions of dollars. So RSA got that in 2002, and there was also a good algorithm called Diffie-Hellman key exchange algorithm. That's again a very good algorithm, because one of the challenges in symmetric cryptography is how do you share a key between source and the destination. Now, the previous options were you send it by post, you give it to somebody, you dial a telephone and then inform. So certain strategies were there how to share a key for locking and unlocking the data between the source and destination, means from the encryption to the decryption. But then the Diffie and the Hellman started working in this area, and they designed a very good algorithm, very efficient algorithm. It's called Diffie-Hellman key exchange algorithm. So it's also considered one of the pioneering work in the area of the information security. And they were awarded the Turing Award in 2015 for their outstanding research work. It's a very good algorithm. Hardly 7 steps are there, and easily this key gets transmitted over the web from the source to the destination. Now, this is again India's contribution, which I always feel proud of, which every one of us should feel proud of. Professor Anil Jain, since many of you are already PhDs or some of you would be pursuing PhD. So he's Professor Anil Jain. We can Google his profile. He's one of the world #1 researcher in the area of computer science. And if you look at the Scopus H index of him is 132. It's mind-boggling. How come a single individual has this high, astonishing H index? So a lot of work has been done by him. He's working in MIT US. So one of the India's proud moment for India in the research in the area of computer science. And again, we have got another researcher, Professor CNR Rao. He's based in India only, and his Scopus H index is 134. Now, he's not working in computer science, but he still thought of sharing it, because he was the first person in India who crossed that H index of 100. H index is called Herschel's index. It's a parameter with the help of which we identify the worth of a researcher, the kind of work he's doing, what value it is adding to his profile as well as to the computer science. So we keep on giving a rank. It's more like a ranking system which keeps on increasing depending on your publication and the citation of your work. So Professor CNR also awarded Bharat Ratna in 2014 because he was the first Indian who was based in India and who crossed that mark of 100 in the H index category. So they are the people who we can draw inspiration from, and we can also guide our students that these are the role models where who can be emulated that for their kind of the creative work they are doing. Now coming back to the blockchain technology, so the real credit goes to Satoshi Nakamoto. He is known for inventing the bitcoins. He implemented the world first blockchain, and he also deployed the world's first decentralized digital currency. So way back in the year 2009, he did it for the very first time. So roughly 11 years have gone by, and the entire cryptocurrency and the blockchain technology, primarily we say he is his brainchild. He was a person behind it. He did a lot of this in this area, but he hid himself behind the scene. So the entire world actually does not know who is real Satoshi Nakamoto. That's one of the biggest hidden secrets we have got. So the entire information security world is confused who is real Satoshi Nakamoto. But the closest person who can be tracked is Dorian Nakamoto, a Japanese who was very active in information security in around 4 years, from 2007 to 2010. So there are many theories on the web, but still there is no precise answer that who is real Satoshi Nakamoto. So he is more like a person who is working behind the scene, and maybe in the years to come he might reveal his real identity, but till now we are really not sure of who he is. Now when we talk of the Bitcoin or the blockchain, so we say it's a decentralized digital currency without a central bank or a single administrator, that can be sent from a user to user on a peer-to-peer Bitcoin network without the need for the adversaries. So we do not require a single centralized authority who can work in the area of the blockchain and Bitcoin. We want to be as decentralized as possible because that is what the USP of the entire blockchain and the Bitcoin is. We don't want to be kept under the control of a government, and they should not be interfering with the working of the cryptocurrencies and the Bitcoins. And the transactions are all verified by network nodes through a cryptography, and they're all recorded in a public distributed ledger called as a blockchain. So all the information will be recorded, they will be kept, but in an open domain where it is visible to everyone. So we can have a look of the first blockchain which was mined by Satoshi Nakamoto. I will just share the URL of the same so that you can also have a look. I've shared the URL in the chat box also. You can click over it to see. This was the first blockchain which was coined by him. So if you scroll it, it shows us the date and the timestamp, 8:24 a.m. in the morning on the 9th January 2009. So that's the timestamp which has been coined. And if you want to have a look of the latest blockchain which is getting generated, which is getting mined, so I will share the URL of that also so that you can click on your system and have a look at it. So you can click on this URL which I have shared in the chat box. So it's a blockchain.com/BTC/blocks, and we can see around 5 minutes back a certain transaction has taken place, and the transaction number has been 6,51,795. And these are all the blocks which are continuously getting created using the blockchain technology, and the entire information is available in the open domain. So right from the first block to the current 6,51,795 block, all the blocks are available on the web, and how the size of the block we can see in the last column, it is also available. So the entire information is there which a person can use and see it. Now let's come to the next part of the Bitcoin mining, what we say the role of the miner. Now miner can be defined as accountant who records every minute of transaction in the blockchain. So these are the person who are managing the records. So miner are same what we call the accountants in the banks or in the accounts offices. So miner keeps a record of the payment which is being getting done between the multiple entities. So we also say they are the record keepers who keep the system updated of the new payments and existing transactions. So we can also summarize them that miners involves creating a hash of block of transactions that cannot be easily forged, protecting the integrity of the entire blockchain without the need of a central system. So they are the person who will keep a track of. If we can emulate more than like just like accountant sitting in the branch of a bank in a physical space. So they will have a ledger. They will keep on recording the information that what all money has credited in the account, how what amount of money has been debited from the account. So they keep a track of all this information, which is being summarized or arranged in the form of the blockchains. Now, the three principles of the blockchain technology, we always say the DIT principles. First is the decentralization, I is the immutability, and T is the transparency. So there are three fundamental pillars for the blockchain technology. Now, decentralization is simple. The name itself tells. It's a true meaning. Don't want to keep things under the control of a single centralized authority or the organization or the government. So all the blockchains are autonomous and they does not have a central governing unit associated with them. Transparency, yes, they're all transparent in real life, meaning thereby that they will have a zero opacity. So they are not going to hide anything. Everything is visible to everyone. So I will share a small video also that how does it work like. It's a very beautiful video by BBC, British Broadcasting Corporation. A small 2-minute video that will give you a good idea that how it typically works in a real-time scenario. And all the blockchain has zero privacy policy, and all the transactions are public and can be viewed by anyone on the network. So they work in a free open domain where everything is visible to everyone. Anyone can see it, anyone can observe it. So everything is transparent, which does not happen in the real-time banking system. In a real-time banking system, everything is very hidden, kept secret. But here the blocks are in the open state. And the other is what we call the immutability features. So immutability, which we all know, it's something that cannot be altered or modified with. It means that once a transaction has been pushed into the blockchain, it cannot be altered or modified with. So once a transaction has been pushed into the blockchain, you are not allowed to change the contents of that particular block, which is a part of the blockchain. So I will discuss a diagram also how there will give a good idea how does a blockchain formation take place. But to clearly have an idea at this point of time, it will be a chain of blocks, and each block will carry certain amount of data inside it. So once the data has been written in it and the transaction got executed, now we cannot alter or modify the content of the particular block. So immutability is a very important feature of the entire blockchain technology. So just general underlying principle, we can say we do not give all the control to one entity, just like we happen in the real-time banking scenario, but trust many entities of the stakeholder because the things are in the open domain in the area of the blockchain technology. So I will share this URL with you. It's a very good video which is the blockchain technology. It gives you a good idea how does a blockchain work in the real-time scenario. It's a small 2-minute video, so I will share the URL. You just click on that link and observe that video for 2 minutes because thereafter our all discussion will be based on that. So you can click on the URL I've shared in the chat box. It's a YouTube video. Just click on it and observe it for 2 minutes, view it for 2 minutes and understand how does it work like in a real-time scenario. I will also start on my own system, but keeping the network issue, I don't know how much it will be visible and audible. So I hope we have seen the audio and the video of it, and that this gives a good idea and the fair idea how the things work. Are the slides audible, visible? And the voice audible? Can we restart the things again?
Yes, sir.
Okay, great. So let us look how the chain of blocks actually gets created in the blockchain world. So initially we'll have a single block. So we denote it by the alphabet called B, rectangular base block. And this we also call it as a genesis block. So that's the very first block which actually gets created on in the entire blockchain world. Now this block will transmit the data to the next block, because what we are doing is we are creating a chain of blocks. So B forwards the information to B1, the next block in the blockchain. So what all does this information getting shared between the block? That's a curiosity that comes into my mind as a person in the information security world. So we can see here we have a few informations written, a four set of information to be precise. First of all, we'll have a hash of the previous block. Whichever was the previous block, we'll calculate the hash of it. Now we can use any of the algorithms, MD1, 2, 3, 4, or 5 algorithm, the message digest algorithm. That's the first thing to be done. Second thing, what is the data we are trying to protect? So we normally just give fiber data, that means my financial data, the insurance data, the banking data, the educational data, the universities or the school colleges data, or it could be the EMR, the electronic medical records, that is the data of the patients in the hospital management system. So broadly, we deal with this five kind of the data in the information security. It could be the timestamp, the date and the time the block was getting created, and then finally the hash of the current block. So every block will have two hash values. First, the hash of my predecessor block, and then my own hash. So hash of the current block, which again we can use MD series of algorithm or the SHA series of algorithm, secure hash algorithm, SHA algorithm, to create a hash of the content of the current block. So that is what is important, or the backbone of the entire blockchain is the hash values. We keep on generating the hash every time uh, for the previous block for my own self. Now for the genesis block, there is no hash of the previous block because that's the first block. So block B0, and there's no predecessor to the so that there will no hash value for the previous block. The idea is more like a linked list, which we normally teach to the students in the data structure. That you create a linked list, and every node will have two parts. It will have a pointer to the next as well as to the previous. Now here we moving towards the next. We keep on forwarding the data to the next block, but every next block will contain the hash of the previous block. So block B1 will forward it to the block 2. Are the slides moving? Are we able to see? A quick yes or no by anyone?
It's still on the chain of blocks where the metadata information is.
Okay, so it's not again moving. Okay, right.
Did you move on the same slide to B2?
Yeah. It was a
Okay,
navigating site. Things are moving now. I've again
okay,
stopped the
yeah. Yeah, I
PowerPoint
think
presentation.
you can restart, then it's moving.
Okay, so this is how it will look like. We'll have a multiple blocks, block B0, B1, B2, B3, B4, and B5. A chain of blocks all connected to one another. And the first block we say is a genesis block, and each and every block will have a hash of its own data, hash of the previous block, then actual data which you are going to transmit, and the timestamp, when was the block created. So date and the timestamp part of it. And then I can have the infinite number of blocks attached in my blockchain. Typically, we set around 255 blocks, but I haven't come across in literature any kind of the limitation on the number of blocks a blockchain can have. So for protection of the data, I can have any kind of any number of the blocks within my blockchain. But again, the key to remember here is the hashing technique. Now, the first thing that should strike my mind is how to go for hashing. So we can use because I work in Java in my lab, and so are my students who work along with me in Java programming language. So in Java, we have got something called JCA, Java Cryptography Architecture. So we can use a JCA, which provide us the inbuilt packages having the interfaces and classes, which provide us the concept of the implementation of the hashing with the predefined algorithms. So let us take a simple example of how the things look like when we go for the blockchain. Is the code visible? A quick yes or no? Is the code on the
Yes,
Eclipse
sir.
visible?
Yes, sir. Yes, sir.
Okay, great. So I'm using the IDE as Eclipse here. So we can use the NetBeans or any other IDE for that matter. Now, these IDEs are primarily used for writing the code for the Java programming language, both the NetBeans and the Eclipse. So we can go through the simple code. What we are doing in the line number 3, we are importing the message digest class. Then I've imported the scanner because we would like to get the input from the user. Scanner classes are used in Java. Then the line number 6, we start with a class, public class name. Then line number 9, we start with the main function. So public static void main, string, args, and the problem arises. So we'll have a matching exception class, which will handle the exception for me. Then in the line number 11, we instantiate the scanner class and we pass input as a keyboard. So system.input. So the user will provide input to me and we store it into a variable. Then we can suppose the input is a credit card number. So we accept the input from the next line function and store it into a str variable. Then we can display the input which we have received from the programmer. So plain text, that is what our input is. So original plain text for the hash generation, we use the SOP statement, system.out.println, and then we display the value of the credit card number which has been input by the user. What our main objective is to calculate the hash value of the credit card number which has been provided as input by the user. Then in the line number 15, we display SOP statement, system.out.println statement, attempting to calculate the message digest. Then in line number 16, we make a call to the get instance function of the message digest class. Now we all know in Java, everything happens on the right hand side, so of the assignment operator. So what we do here, we make a call to get instance function, pass MD5 as a parameter. Now, if this is successful, so it will return a value. So what we'll do, what type of value it will return? It will return a type message digest type because we are making a call to the get instance function of the message digest class. So after the execution of line number 16, MD, which is a reference variable of the message digest class, will hold on to the instance of the MD5 algorithm. So if I want to have a SHA, I can use the SHA algorithm. If I want to use MD1, 2, 3, 4, or 5, the message digest algorithm, I can accordingly pass the name of the function. So now this is already available because at the line number 3, we have already imported the message digest class. So there will not be any problem. However, if there is a problem and the MD5 algorithm is not available at runtime or instance cannot be created, we already have used the exception class. And in Java, we all know there are 4 or 5 ways how we handle the exception handling: try, catch, throw, throws, and finally. So instead of writing the code with the try catch, we have right at the time of function definition, we are using the throws keyword and the appropriate exception class for it. Now everything is fine and well. We move to the line number 17. Now what we do in the line number 17, we have already obtained the instance to the MD5. Now what we want, these function work on the bytes rather than on the string. So what we do, the user has already provided us an input in a str variable, the credit card number. Now for this variable, we make a call to the get bytes function and we pass the encoding scheme. So encoding scheme is a UTF-8. It's called Universal Character Set Transformation Format, UTF. So there are multiple encoding scheme, like we have got UTF-8, UTF-16, and UTF-32. And all these encoding schemes have their own predefined purpose, but it will be not feasible for us to talk in detail during this part of the lecture because time is running out. So we use the encoding scheme and we fetch the bytes from the given string. Now since we are fetching the bytes, so we create a byte array variable called BA that will hold on to the bytes of the given input string. What is there in the string? My credit card number. What do we do after that? We make a call to the update function of the message digest class. So MD is a reference variable of the message digest. We make a call to the update function and pass the byte content of the string here. So BA is currently holding on to the byte content of the string, and the string is our credit card number. And we pass it to the update function of the message digest class, because now we are moving toward the final stage to create a message digest, the hash value for the given number. Then what we do finally, we make a call to the digest function of the message digest. So MD dot digest function, and then it will create a hash value for us. So what we are calling it here digest here. Digest is same as the hash value, and we create a byte array by the name digest. So this digest is currently holding on to the hash value which has got generated using the MD5 algorithm on the given credit card number. And if we are able to successfully execute line number 19, we say SOP statement, it has been success. However, if the exception can be thrown and the program will terminate. And then we can display the same hash value back to the end user. So hash tag is, and since currently the contents are in the form of bytes, so we make a call to the value of function of the string class over a digest variable. So we fetch the string contents from a byte and display to the end user. And then finally we say program execution is successful and we stop the program. So this is a simple way. In hardly 20 lines of code, we can write a small Java cryptography architecture based program to calculate the hash value for a given plain text. The plain text here is the credit card number. Now we can just quickly run the program, and it's a small program. I will share the code if you would like to work on the JCA. So the two programming which are very popular for the blockchain is either we can go for Python or we go for the Java programming language. So let me restart the Eclipse once again, and then we will see the output. In the meantime, we can go through the presentation. Yeah. So this is how the blocks look like. So we'll have block 0, block 1, block 2, and block n. There could be n number of blocks in it. And every block will have the empty. The first block, the genesis block, will have an empty hash value of the predecessor block because it is not connected to anything. And then we have got the hash value of the successive blocks. Now let's come to the Ethereum part of it. Ethereum is a very popular distributed blockchain network that enables a developer to build and deploy various types of the decentralized application very easily. So when we talk of the blockchain and the cryptocurrency, Ethereum is a very good platform which a lot of work is being continuously being done by the different experts, information security experts, and working in the area of the information security using the Ethereum as a basic fundamental concept. It was first proposed by Vitalik Buterin, and that too way back in the year 2013. Now, if you Google his profile, he is one of the good technocrat, a very smart boy, hardly 25 years of age, and he has done a lot of work in the area of the Ethereum because he is based in Canada and he has done tremendous work designing new technologies for the blockchain. And it is currently being used across all the world, the cryptocurrency using the Ethereum concept. So Ethereum helps in designing and issuing the cryptocurrencies and the credible digital tokens. And it's very popular. I will share some of the URLs where they are currently being using. Just like we got a Binance.com. So again, it's a very popular cryptocurrency exchange. So I'm just sharing the URL of it So you can also open it at your own systems. So it's a binance.com/in. You just click it over, and then you will be able to go through this cryptocurrency exchange where a lot of transaction is being done in the using the Ethereum. So you can buy and sell the cryptocurrencies within a few minutes, and there are many number of the cryptocurrencies available. You've got the BNB, the BTC, the ETH, XRP, Ripple, Bitcoin Cash, Litecoin, and if the person want to do trading using any of these cryptocurrencies, they're all possible. Then the other is the bankchaintech.com. It's again very popular site, which wherein the multiple banks of India, they've all come together to share this information about the multiple cryptocurrencies they are going to deal with, and they also share about the products in which they will be working and dealing across all over India. So if you can see at the bank chain members and partners, almost all the banks are there. If you go to the SBI, ICICI Bank, Kotak Mahindra, the South Indian Bank, Bank of Baroda, many number of the banks are there. They're all working together to make sure that the cryptocurrency become a hit or successful venture in India. And since it is being backed by the SBI, so we can always trust them that yes, whatever they will do for the benefit of the customers, because the government has a lot of stake in the SBI. So it's a portal. You can click here and share the URL in the chat box. It's called bankchaintech.com. Moving on, we have something to do called the smart contract. A smart contract is a very important part of the blockchain world, wherein we carry out an agreement between the two entities. A contract word typically means the same thing. Agreement between the two ends or the two parties. So Nick Szabo is a person who introduced this concept for the very first time, and it can allow anyone to trade currency, property, or any valuable thing in a very simple and hassle-free manner. So once you have signed a contract between the two entities using a blockchain technology, then you can execute that contract taking the principles of the smart contract feature in the blockchain. So it helps to detect the user or anyone cannot avoid the frauds of a middleman. So its primary objective is again protect or safeguard the rights of a customer, his money, so that it doesn't go into the hands of the criminals. And the user can also compare it with the simple concept of the C language, what we call the if, then, and else statement. So if one condition is fulfilled, then a particular condition will take place. And if a particular condition is not met, then some other will take place. So it's more like a coded statements we sign within a smart contract. So you specify a condition: if this will happen, then this will happen, else if this will happen, and finally else to conclude with the and if. So smart contracts which are written using a blockchain, we say they are all committed codes, and that simply means that when an outline of the event can take place, the smart contracts are usually triggered up. So there are predefined contract things where everything is written very crystal clear in black and white, that these are the set of events that will take place, and all these events are now coded with the hash functions, so they remain a part of that blockchain world forever. Nobody can now tamper them or modify them as such. We can take a simple example to have a better understanding. If in a corporate organization, if the targets are reached, then the bonus should be given to the employees. Something like an auto event, or more like a triggers in a databases. Just like we have got the before the insertion of record or after the insertion of the record. On the same way, here we'll have events which will have a triggering value attached to it. Let's take this simple slide as an example. I'm showing in F5 mode, PowerPoint presentation mode. Hope it's visible. It's a predefined contract which is written on the left-hand side. So all the terms of the policy are agreed by all the counterparties, and these are all hard-coded into the smart contract and cannot be changed without the parties knowing it. So every event will have attached thing that what will, for example, insurance company.
So event triggers insurance policy execution. So if I'm taking a policy from a company, so I will sign a contract, a smart contract with a company, that in case of any eventuality in my house, or me passing away, or whatever I specified the precondition. If there's a fire in my house, if my car gets stolen, any kind of the events, then I should be compensated. So the smart contract policy is automatically executed based on the pre-agreed terms. Means at that point of time, the insurance company should settle the claim fast, instantly. It should not put any restrictions on the claims and damages. So payout or the other settlement are completely, instantly and efficiently, so that the customer at the end of the day does not have to face problems and hassles in getting the claims of the settlement. Since he's already signed a pre-smart contract with the insurance company, then the money should be instantly rewarded to him, and he should get the instant payout or the bail packages from the company. So we can have a smart contract written for almost every kind of the banking sector, the financial sector, means wherever we have got multiple stakeholders or multiple parties in an agreement with each other. So using the blockchain, they are going to the committed mode. They cannot back off because the information is in a decentralized manner. It's hashed, it's coded, it's secured in a block, and nobody can back off. That there are certain, they cannot impose the restrictions later on. Whatever other terms they want, they should specify in the beginning only. They should not specify any terms later on as well. So smart contract is getting very fast popularity in the blockchain. It has been introduced recently only. So, but using the concept of the hashing, not many companies are now coming into it, and they are making all the transactions secure using the concepts of the hashing, using the MD5 or the SHA algorithm, any other kind of the hashing based algorithm. Now, there are a lot many companies also who are working in this. For example, IBM is one of them. So IBM blockchain solutions are very popular. They are delving a lot. So is Oracle. They are also coming with their own blockchain-based products, and these products are getting a lot of popularity in the information security. We have also got blockchain council. If you are interested, you can become a member of the blockchain council and start working for the in this area. They have got a lot many products which are getting designed and developed using the benefits or harnessing the power or the benefits of the blockchain. And there's a very good course by the IIT Madras. So if you would like to forward the information to your student, or maybe you yourself would like to join some course to getting a good knowledge of the blockchain, it's a very popular course. So I'm sharing the URL of it. It's around 8 or 9 months course dedicated on the blockchain technology, IoT, and the cloud computing. Since I'm a part of it, so I thought of sharing it. The rest you can forward it to the students if they're interested. So they can also register and enroll for the course if they feel like doing it. Now we can come to the Government of India's blockchain-based virtual lab, which they have done a very good work to spread the knowledge about the blockchain, how the blockchain works, designing a simple simulation examples wherein the students can learn on their own, or maybe just using simple experiment, they can actually replicate the features of the blockchain. So I'm sharing a link, and I will also give a demo, which is wherein you can replicate the same thing at your system also. So I've shared the virtual lab scenario URL in the chat box. You can click it over. Have you received the URL? Just open it at your system also. Is it visible on the desktop? Anyone can say quick yes or no?
Yes, sir.
Okay, fine. So this is there are multiple exercises here. This is a very simple and the smallest exercise. So I will just give a demo of how it works. You can get a fair idea. So here in the very first blockchain exercise, there are 4 nodes. Let's say A, B, C, and D. Now they also give the instructions here on the right hand side. Connect to the block circles in the order specified below to make a valid chain. So I can use the instructions, or I can use my own logic to connect the multiple nodes. So how do we connect them? We click on a source node, that is say A, we click on the destination node D, and then a horizontal line comes, an edge comes connecting the 2 nodes in a graph. So a single edge is there connecting the A to the B. Now, what I do here, I click on the node B and click on the node D. And now these two nodes are also connected to each other. Now I want to check whether what I am doing is right or wrong. So there is a push button at the bottom in the green color called validate. So you click on validate and immediately a notification comes that there is something wrong. It's invalid. Because what I have done, I should follow the sequence what they have written here. So point I am trying to say is very helpful to the students that whenever they get off the track, they can correct. And then a valid blockchain is one which follows the concept of the hashing, right from the genesis block to the last block. So what I can do, I can reset here and then everything will be clean off. Now here they say the first instruction B to D. Now I am a good student, I am following the instruction. I click on B, I click on D and I connect the two to each other. Now I want to validate whether it is correct or not. So I click on the validate button. Again, it says invalid because the entire instructions have to be done. So what I can do, I can maybe reset again. I follow the earlier path A, connect to B. Now from the B, I connect to D. From the D, I connect to C. And I can keep on checking whether what I am doing is valid or invalid as such. So now if you see the transaction number 3, now it is correct. It is given popping third notification, it is a valid transactions. So otherwise they will keep on popping the notation. It is invalid, it is not following the syntax, it is not following the convention, and we will have to reset it again as such. So this is a very small simple exercise which helps us to guide how do we create a blockchain in a virtual lab scenario. So this is a good setup by the Ministry of Human Resource Development, now it's called Ministry of Education, wherein they have designed small experiments and examples to simulate the concept of the blockchain. Now we can move on to another example called Initiate Open Ledger Experiment on the right top. You can click it over. And then now in this experiment, what they have done, they have designed an open ledger. And they have given some options on the left hand side. So here they say enter the name of the user. Let's say I enter the name of the user as Amit. Now I enter certain amount to him. Let us say I give him 1,000 credit, $1,000. And I click on the submit button. So a system has deposited an amount of $1,000 to the Amit. Now we can give another name of the user. Let's say I enter the name as Amita. Now Amit transfers, let us say from the $1,000, he transfers $500 to Amita. So we can click on submit button and now we can see another note where the Amit transfer $500 to Amita, and now Amit is having $500 and the Amita is also having the $500. So you can see here from and the to comes and get written within the rectangular box. Now it prompts us, do you wish to continue? You can click on the yes. And now we can enter the other name of the beneficiary. Let us say we enter the name Savita. Now Amita transfers $250 to Savita. And we click on the submit button. So we can see here our open ledger is getting created. First of all, we initially inputted $1,000 to Amit. We gave $1,000 to him to start off the transaction process. Then the sequence of instructions keep on happening and one person become a creditor, the other person ends up becoming a debtor. And the transaction flows. So that is what the only thing which we need to take care is what written in the step 5. Amount which you enter in the second and the third transaction should be less than or equal to the amount which you received. So it should not happen that you have received $500 and you are transferring $700. So that kind of situation should not happen. Otherwise, the experiment keeps on getting populated and multiple nodes become a part of this open ledger experiment. Then we can move on to another experiment called Initiate Distributed Ledger Experiment with a name written on the right hand side. We can click on this button and we come to this experiment where instructions are already written on the left hand side, and then we have this scenario of distribution where we have multiple blocks, block A, block B and block C, and there's certain amount of the money which is keeping getting exchanged between the node A to the node B, which is the part of the block A, then node B to the node C, which is the part of the block B, then again ABC share amount in the block C. So we have got multiple nodes. They are all sharing the currency, they're all sharing the money within their own blocks. So let us say I take a first block and I click back on the node A. I click on the block B and then I click on the node A. I click on the block C and I click on the node A. So node A is continuously sequentially it is maintaining the block. So hash values are kept getting intact because we cannot shuffle the sequence of block where hash value will get disturbed. So I replicate the same thing in the node B. So I use a block A, I use a block B, I use a block C. So I have got block A, B and C within the node B. Then I do the same thing for the node C. So I have got block A, block B and the block C. So now my entire transaction is getting ready and it is done. Done in the sense that all the things are now arranged and all the blocks are sequentially getting arranged and all the hash values are getting intact. Now I would like to check whether I have done is right or wrong. So I click on validate. And one notification will come on the top that valid means because I have maintained the integrity of the hash and all the blocks are sequentially arranged in the node, so it becomes a valid one. Now let us do something and fiddle with it. So I reset it here and I again arrange the sequence of block in the nodes. So in the node A, I maintain the integrity of the hash and I connect block A, B and C in sequential. What I do in node B, again I maintain the integrity of the hash and I arrange all the three blocks A, B and C in sequence in node B. Now in the node C, I place block A, then intentionally or unintentionally, I just change around the sequence of block. After the block A, I introduce a block C, and after the block C, I introduce the block B, maybe deliberately or indeliberately. And I want to check whether it's fine. Then I get a second notification that order of block is different and therefore it is invalid because the hash values have got disturbed. So a simple experiment to show the essence and the value that all the blocks should be arranged sequentially to one another and they should be arranged properly in the node which are a part of the blockchain. So these are small experiments which are being a part of this virtual lab. So as and when you plan to give a small lecture or talk to the blockchain to your students, maybe you can simulate, you can show the virtual lab because it's a free of cost open source. Else we can go for any of the commercial product like by the IBM or the Google, but they're all paid. So funding becomes a big issue. So that is all from my side. If there's any queries or doubts, feel free to unmute yourself and ask a question. I'll be more than happy to help. Any doubt, any query? If there's any query, you can unmute yourself and ask.
Any queries from the participant? Queries and writing on chat box.
Question I think what she is asking is blockchain really the ultimate solution? There is no ultimate solution to any kind of problem. What my experience says, there's
it's the next best thing in the sequence of the things in the information security. But is it the final solution? No, it's not. There are many more technologies which are currently the work is getting done. So we cannot say it's a final thing for the uh, solution world. But yes, it's one of the good technology which is going to be bright futures, because a lot of work is being getting done. A lot of the companies are putting their money onto it. A lot of funding is there. So it is a solution, good solution. I don't say it's the ultimate solution, but it's a very good solutions for the kind of work which is being done in the area of the information security. It's good in terms of, because it uses the best of the cryptography techniques, it uses the best of cryptographic algorithms, it uses the well-designed and developed hashing technique. So when I'm working for any of the company, let's say maybe any of the Paytm or any of the digital wallet company like PhonePe, etc., and if I'm using a blockchain technology, it's very clear I will not be using a predefined algorithms like MD5 or SHA. I will design my own technique. I will design my own hashing algorithm, because I cannot use a predefined algorithm, because these algorithms are already known in the open source. They're already known to the open world. So working with a proprietary company, I have to design my own hashing technique. I have to design my own hashing algorithm. I cannot use the predefined algorithm in the commercial world, because all the cyber attackers are very smart. They all are very efficient in launching the attack. So multiple attacks. I hope with every one of you will be familiar attending this FDP. We have got a man in the middle attack, and the brute force attack, the dictionary attack, the birthday attack, the replay attack, the masquerading attack, the modification attack, the denial of service attack, distributed denial of service attack. There are millions of attacks already known, and many of them are not known. So we cannot use a known technique or algorithm which is already known in the academia for safety and security of the data when we're working for the commercial companies. So coming back to the answer, no, it's not the ultimate solution, but yes, it is a good solution in the whole set of solutions which are available right now, because it uses the strong concept of the hashing. And there are two hash which are being used, one for my previous block and one for the current block. So using a double hash, it gives me the strong power to harness the capability of exploiting the hash for security of my data. So this was the example which we were taking. Let's quickly go through it. Is it visible there? A quick yes or no?
Yes, sir.
Okay, fine. So we enter credit card number. Let's say any 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, and 1, 2, 3, 4, 5, 6. Because we all know credit card is 16-digit long. So we prompt the user to enter the credit card number, and then this is the received number. Then we calculate the hash value. Result has been successful, and this is a hash value which we generate of a given credit card number using the MD5 algorithm. Now this is the hash value which is a string equivalent of the bytes which have been generated by the MD5 algorithm. So now this is one of the hash value. When we design and develop a blockchain, there will be so many hash values, and every block will have a two set of hash values. One having the hash value of the previous block, and one the hash value of my own block, and together with the timestamp and the data which I would like to secure. So there are four entities in any block in a blockchain: the hash value of the previous block, the hash value of the current block, the data, which could be financial data, the banking data, the insurance company data, the educational sector data. For example, if I'm working in a university and my, let's say, university is 50 years old, so there are a lot many students who have passed out in so many programs in my university. Now I would like to safeguard their educational data. So blockchain is one of the good area wherein I can encrypt the data of all the students who are passing out, and then safeguard it. So even if they're 10 years or 20 years, they come down for the issue of their mark sheet or degree, I have their data protected in the form of the blockchain. So I can decrypt it, and then the data is available to me. So because we do not lose the data when we deal with the hashes. So I can safeguard their data safely and securely using the hashes in the blockchain. And the data doesn't get corrupted, doesn't get violated, and the bit integrity remains intact. And since we are dealing with two hashes in every block of the blockchain, so security is very good in this. Any other doubts or queries? I'll be glad to handle it.
So what are the primary disadvantages of using advantages and disadvantages of using blockchain over the traditional hashing methods?
See, other hashings, when we talk about the plain symmetric cryptography and asymmetric cryptography, they were just dealing with the cryptographic techniques and algorithms. Like taking any of the Caesar cipher, the Veneer cipher, the Railfen cipher, affine cipher, they were just having small equations of P plus K mod of 26, something like that, when we talk of the Caesar cipher. They were not dealing with the hashing. So any technology that is built around the hashing has much more higher level of security. It gives a feeling of strength and robustness to the technology. So it's yes superior, far better as compared to using any of the plain cryptographic techniques and algorithm for the security of the data. There's a question by Dr. Lakshmi, why there's so much hype around the blockchain technology. Hype is something which we in IT industry create. Technology is okay, fine. You look at the hype around IoT. IoT has been there for the last 10 years, but so much things are being said about the Internet of Things. Look at the around the blockchain. Look at the cloud computing. So we in IT industry have that habit of creating the hype around anything. Look at the big data. The data, these are the technologies which have been there for almost. In fact, if you there's a Professor Jayant Haritsa in ISC Bangalore. He's working databases, is considered as the father of databases in India. He was the person who organized first databases conference on VLDB way back in the 1976. So data has been there from that era, but now so much hype is being built around because it's a hype created by companies, not by individuals. We in academia and research don't create hypes. You and me are just teachers, more like academic educators. We don't create hype. It's a big $1 million companies like Microsoft, Adobe, Amazon, Google, and IBM, the multi-million-dollar companies. They got a huge amount of money. They decide when to push the technologies, when to pull the technologies. Whenever they would like to make sure any technology become popular, the hypes are developed around by the media and by the companies concerned. Otherwise, technology is simple technology, just like any other secure and safe cryptography, any technique which uses the hashing concept and works in the area of the information security. Any other doubt or query?
Going forward, is it possible to mine crypto using mobile technology? Because there are a few companies which are coming with the concept that since blockchain mining is a heavy computation, so they are coming up with lightweight blockchain.
Yes. As I said during my lecture also, we are also working in the same areas, how to design and develop a lightweight cryptography algorithms which can harness the power of blockchain technology, and these algorithms can work efficiently, seamlessly on the handheld devices using which work in the area of the wireless network. Because one of the biggest problem of these handheld devices is that power is an issue. How to keep on charging the battery of the particular nodes. So in India, solar power is abundance. So that's again an open research issue. Many of the companies working in hardware can come up with the devices which are solar power driven, because in a country like us, out of 12 months, 10 months, there's abundance of solar power. But not much work is being done on solar powered smartphone because all the technology is done in the Europe and US. And there they don't have abundance in solar power. So they don't spend a huge amount of the funding in research in design and development of the smartphone which can harness the solar power for the energizing of the battery. But yes, in India, in entire Asia Pacific and Asia region, there's an abundance of solar power. So if we can devise a security technique which can build around the solar power energy and then uses the cryptographic techniques and algorithm and use the hashing also, it will be a next generation technology, which because there we don't have to worry about the battery life of the node, because we'll trap the solar power. We have already got the solar powered calculators and school kids already use it, but we don't have a solar powered smartphones. But yes, the time has come that we I think some of the company might be doing a research in that, though on the literature survey not much research papers are there on it. But yes, it's one of the big domain wherein we can have the lightweight solar powered devices, and then cryptography technique which also uses less amount of the computation power without compromising the level of the security. So any other doubt?
Sir, how to reduce the complexity in computation to make the simpler use in Bitcoin?
See, security should not be compromised in any sense, because that is something I am not in favor of. but yes, we can always try to develop and design the algorithms which can reduce the level of complexity without compromising the security. And there's always a trade-off in this. That depends upon the ultimate research group who is developing the technology, that they have to identify the parameters first, that what are the focus areas in which they would like to work on, and they should not compromise the level of security. It should not be vulnerable to hackers. The attack should not be imposed, and the underlying devices have to be taken care of. That energy issues are there, we already know. So it's a bit trade-off, and though no final answer can be given to it, that yes, how we can do it, but it's a continuous process. You keep on designing and developing the next general algorithm, and we all know we evaluate the algorithm on the basis of time and the space complexity. So our next generation of algorithms, which are very energy efficient, which uses less of the computation power, less number of CPU cycles, but still do not compromise on the level of security. So that is something which is a good PhD research topic, something I must say. Any other doubt? I've shared a URL of my lab. If you've got any doubts or queries, you can always post a
Sir,
query to me on WhatsApp, on my mail. Yeah, please go ahead.
sure. Thank you, sir. It was very informative and very for our like the challenges in and complexity. PPT and the so
So thanks a lot. Thank you, Professor Harsh Vikram Singh ji, for inviting me to deliver a talk on the blockchain technology. If you have already any doubt, you can always drop me a mail. So thank you, everyone.
thank you, sir. Thank you very much, sir. So, participants,
Welcome.
now this is the end of the day. Uh, so we will meet at 10:30 tomorrow, last session, last day of the this FDP. So tomorrow we will do some short assessment test and feedback form will be sent to you by the AICT and attendance tomorrow afternoon will compile AICT. If you have any issues regarding not giving the attendance in any session, please drop mail or WhatsApp to me, not in the group, personal WhatsApp. Then we will resolve all these issues. Thank you for joining. Okay. So to